Okay, so what we're going to do is review what we did last time, which was starting off with Gauss's method of solving linear systems. Okay, so let's look at a linear system. Let's say 2x plus Sonia, I am recording this little segment here.
Great, thank you.
Okay, so here's a linear system, 3 equations and three variables. And so we've put each equation in a standard format where the columns are x's, y's, and z's, and these are the constants in each equation, and each one of these is a linear combination on the left. So we have the linear combination here equals a constant, and the linear combination is a sum of terms, each one of which is linear because it only has one variable, and that one variable occurs to the first power, not squared, not 1 over the variable. So we have a linear system. Okay, and the goal is to find all the values of x, y, and z such that all 3 equations are true. Now, geometrically, like each of these equations defines a plane in a 3-dimensional space, which is hard to visualize, but in the text in chapter 1, it goes through and sort of gives you some pictures and examples of a linear system with a system like this that shows you what the possibilities are for the 3 planes. Because if all 3 equations are true, geometrically, what that would correspond to is all 3 planes intersecting in the same thing. And they might intersect, they might not intersect at all. They might intersect in a line, or they might intersect in a plane. And so, and they might intersect in one point. And it's going to turn out that those are the only 3 possibilities. So what does Gauss's method do? Well, what Gauss's method does is it's going to apply one of the 3 operations, one of the 3 row operations, and those are rescaling, which is multiplying a row by a number, by a non-zero number. Okay. The second one is swap. You swap 2 rows. The third one is a row combination. And this one says you add a multiple of one row to another. Okay, so we want to have a notation for each of these row operations. And so these are called elementary row operations, and we're always going to do 1 row operation per step. So here's the notation. It involves the Greek letter now. See the way I drew this? This is not a P. The way you draw a P is to start at the top, go down, and then come up here. There's a little edge here. The way you draw a row is to start at the bottom and come up in a little circle. So it has a rounded corner. There's no sharp edge there, okay? So you pronounce this as in, it rhymes or sounds exactly like row. If you wrote it as a Greek letter, you probably might write RHO instead of ROW, but it's pronounced row. So you could, if you could sort of tell if you're pronounce this correctly if this song makes sense. Okay. So the notation is this: involving row. For a given linear system, there's three rows: 1, 2, and 3. And we're going to say, let's say we wanted to multiply row 1 by 2, by 2, or say by 3. If we want to multiply row 1 by, say, 5, we would say 5 row 1. That's our notation. This means multiply row 1 by 5. This would mean multiply row 2 by 3. So I need to put my linear system here. So I will come down here and, okay, so multiplying row 1 by the number 2, that's an example of our notation for a row rescaling operation. Our row swap operation would be row 1. This swaps rows 1 and 3. Our third one is, let's say we wanted to add 2 times row 1 plus row 2. Okay, this says this one's, I'm going to I always have to write the one I'm going to modify second. And so this instruction is multiply row 1 by 2 and add it to row 2. And this becomes the new row 2. So this one means add a multiple of row 1, 2 times row 1, add it to row 2. That becomes the new row 2. It doesn't change row 1. Now, this is invalid. This is not an elementary row operation because this involves multiplying row 2 by -1 and adding 2. This is a combination of 2 operations, so we're not allowed to do this. I mean, in principle, this would be fine, but I'm gonna say no. We're not going to use this notation. Another notation I'm going to not allow is something like this, where you put a number. So the only thing you can do is you have to have a plus here and a operation here. This could be plus or minus, and so that's the row combination operation. Now, so we're going to use that notation to transform this linear system into a form in which we can do back substitution in order to solve it easily. So, and to do that, we need to put it in a row echelon form. Now, row echelon, this is not in row echelon form because the leading term in each row has non-zero terms underneath it. So the leading term in row 1 is this one here. So we need to get rid of this term and this term. Now, once we do that, we can come over here and say, well, if this is still here, we need to make sure that this term is 0. So the idea here is to work sort of on the first column. Once that's done, then we come and work on the second column. And then the third column we for free because this will be the leading term and nothing's underneath it. So any questions about our strategy so far? Okay. So what I'm going to do is see, if I multiply this first, just worrying about the first term, if I multiply this first term by -2 and add it here, it will get rid of this term here. So my row operation I'm going to do is -2 row 1 plus row 2. And we're going to sort of put that over as an arrow. Usually we'll draw this on the right, but I've drawn this too big and there's stuff over here. So we will, on the next page, we'll get down there. Now you have to recopy the entire system. So what we do is we don't change the first row. And we take, so the way we do this is we're going to multiply -2 times the first term and add it to the second term below it. So -2 times this is -4. x minus 4x plus 4x is 0. Then minus 2 times this is minus 6. Minus 6y plus 9y is 3y. If you see me making an error, then do tell me. Now here we multiply minus 2 times 8z is minus 16z, which gets rid of this one. And then minus 2 times this is minus 40 plus 16 is minus 24. Let's see. If I add 40, so I think that's correct. Minus 40 plus 16 is minus 30, minus 6 is minus 24. And then we repeat the last row. Okay, so there's a transform system. There's a theorem that we're going to look at eventually that will tell us that this system and this system have exactly the same set of solutions. So if three numbers, Sx, Sy, Sz, solve this system, meaning that I choose three numbers, a number for X, a number for Y, a number for Z, and all three equations will become true. If that's true for this system, it's also true for this system. So if I solve this system, I've solved this system. So what we're doing is we're transforming our system into a simpler version of itself. Now, we're closer to echelon form, but we need to get rid of this term. So the obvious row operation to do is minus 3 row 1 plus row 3. Now, okay, so let's do that. Well, we don't change the first row, so we have to repeat it. We can if we want to, we can leave off the zeros, but we have to keep the spacing. So for example, we can say we have to keep this sort of lined up. So you can't move the variables have to stay lined up. Okay. Now we're going to add so minus 3 times 2x is minus 6. That's going to put a 0 here. Then minus 3 times 3y is minus 9y. It's going to give me 3y. Okay, and then minus 3 times 8 is minus 24. Minus 24 plus 20 is minus 4z equals, and then this is minus 60. Minus 60 plus 40 is minus 20. Okay. And now we have nothing underneath this first one. So then we're sort of, this is what we want to get into echelon form for the first row. Now, the problem is this is still not an echelon form as a system because the leading term in the second row, 3y, has something underneath it. So we need to get rid of this term. So we can do that with minus row 2 plus row 3. Okay, so we don't change the first one or the second one. Okay. So we have the first row written, the second row written, and then we're going to add minus this row to this. Well, this one then cancels off that, so we get a 0 there. And then we're going to have minus 8 plus minus 4 is minus 12. Z equals minus 20. And this is an echelon form. Let me erase this 0 here just to make it. Okay, so because we have, the leading row, the leading term in each row is to the right of the leading term in the previous row. So this term is to the right of this term. This term is to the right of this term when they're lined up. another way to say that is there's nothing under the leading term in the first row. There's zeros there. There's only zero terms under the leading term in the second row, and the same is true. There's nothing because there's no rows down here of the leading term in the third row. So this is an echelon form. It forms a staircase. Okay.
Professor,
Shane, you had a question?
you went from -4 to -12
Let's see.
because
I multiply. Oh, this is minus. Oh, this is. Oh, so I made a mistake here, right? Obviously, because the mistake I made was to add. I added minus the first row, so this is 0. So this is just going to be -4.
and
Okay.
then the -20. Shouldn't that be
Minus. Yeah, this should be
+4?
-20, and this would be minus 40. Okay.
I
Anyone
think
else see?
that's still wrong because isn't it the second row? So it should be
I've done
uh
it again. I'm fixated on the first row. Okay, so minus 20 minus a minus 24 is 24. 24 plus minus 20 is 4, right? Do you guys agree now? Well, we can see because we can check, because what's going to happen is there's only going to be one solution, and we can then put it back in and see if it works. Okay, well, now this is an echelon form, and hopefully I've done the numbers correctly, and we'll have to check that because it is, we have to go back and check it. Hopefully we'll see at the end. Now we do back substitution. And that means starting at the bottom, solving for the variable in the last line, and then going back up and plugging it in. So we can solve this, the third equation for z equals -1. Okay, so you put -1 here, -1 times -4 is 4. Okay, the second equation, since there's no z here, we can just solve that one individually too. That's going to be y equals minus 3/8 is 24. So y is -8, right? And so now we know z and y. And so the first equation is 2x plus 3 times -8 plus 8 times -1 equals 20. And this is minus 3/8 is -24. Then minus another -8 here is going to be -32. And if I add 32 to both sides, that's going to give me 2x equals 32 plus should be 52. Well, let's see. If I add 8, if I add this to this side, it'll be 28. So I add 28 and 24. So I think that might be correct. Then I can solve this for I think x equals 26. So there's one solution, and we'll hopefully, let's see. So if given this is correct, how would we write the solution? So our tentative solution is S equals the set of the 1 triple x equal 26, y equals -8, and z equals -1. Now, 26, let's see. So we can see whether this would be something like 52. You can see that you could go through and substitute this in and check whether or not this was correct. And so you can see that you need to do a checks oftentimes because this is sort of intricate system, but it's pretty mechanical. It's like you're guaranteed that the method works. So it's the bookkeeping is a little tedious. And in fact, later on, we're going to find a simplified way that involves matrices and vectors to um, simplify so the bookkeeping, because you notice that we keep having to repeat the X, the Y, and the Z, and they always stay in the same place. And we have to repeat the pluses, the equal sign. So if we sort of got rid of that and just use the coefficients, that would simplify the bookkeeping, and it would also lead to a further mathematical um, idea, which is will be the heart of the course. Okay, so just as a prelude, although we don't have to, we need this for the first assignment. And one of the things we'll begin to do is, this is an ordered triple. Like if I was, this is sort of an X, a Y, and a Z coordinate. And what we're going to do is we're going to begin to write at some point all these items as something called a vector. Now, a vector is for this case, is going to be, we're going to have all our vectors vertical. You may be used to horizontal vectors, or maybe not vectors at all. So here's a vector. It's the same numbers, 26 minus 8 minus 1. It's a column vector. So on the homework, the way you'd write this solution would be, okay, this is also one reason why I'm going to want you to do your homework in licks, because for example, on your first homework assignment, you have to do one of these where you write out all these steps and include them in, your homework. And the issue is, if you're doing it on paper and you make a mistake, well, and you've then it's like it's harder to correct it. It's a little bit, it's going to be easier to actually do this, because you have to keep copying this over and over again and do it neatly. And many people's handwriting, mine included, is not always up to the task of keeping this well presented. So on the Lix editor, we'll be able to cut and paste stuff and then edit it in order to make these row operations. And then if you make a mistake, editing it there is much easier and doesn't involve like necessarily rewriting stuff as much. Okay, so we have that to do, and we have to practice this. Initially, we're just there. This we haven't seen yet how exactly to do the case when you have more than one. How you want to write the answer, the solution set when you have more than one solution. It's obvious how to do this when we have one solution. And some systems might give you no solutions, and that would be easy to write also. Either this, or this is the empty set. This is the case where there's no solutions. That is, there's some conflict in the sense that those three equations up here aren't going to work, right? They define three planes, and these three planes intersect in one point, but two of them could be parallel to each other. Two planes could be parallel, and then there'd be no intersection, so there could be no solution. So you're not guaranteed of getting a solution. And then there could be an infinite number of solutions. They can be a plane or a line, and that's the one that requires a little bit more care to write down. So we're going to hold off on that, of course, till next week. But this is the entire method that we're looking at in chapter 1 to start off with, which is Gauss's method, which is you use these three row operations. We have a notation for that operation. And the way that we'll usually write this as would be, you have a linear system here. We'll have an arrow, and then we'll have, say, and then we'll have a copied linear system. Then we'll have another row operation and a copied linear system here. And then we'll come down here and you'd have the final echelon form. Then you would do back substitution. then you write out the answer as a what's going to be a set of vectors. Right now, we're just doing coordinate. We're just doing coordinate. Coordinates are like here's a coordinate triple. This is a coordinate triple, and the vector that corresponds to that would be 1, 2, and 3. This is a vector. This is a coordinate triple. So this is used to locate, to identify a solution as 3 numbers, and it also corresponds to the notation for the coordinates in geometry. Like if I had an X, a Y, and a Z axes, then this would sort of be like 1, 2, and 3, and that would locate a point in this space. But the vector, we call it a vector because you can do more stuff with it. You can multiply vectors by other numbers. You can add 2 vectors together and get new vectors. And so that's that there's going to be a use for these that we're going to distinguish the notation for the different. This is used, the triple is used to locate, the coordinate triple is used to locate points in space. The vector is used to do algebraic operations. We'll eventually multiply these by matrices, which we haven't introduced yet. Okay, so that's our game for chapter 1. What we want to do now is practice that. And so we'll look over and we'll set some problems, and I'll have you guys work on them, and we'll break up into groups. And now this is where it's going to help if you guys, okay, I'll answer Sonia the question in a second. It'll help if you guys in a small group can actually see each other's work. That's not possible if each of you are doing it on paper. So then it becomes much more of an isolated exercise in which it's harder then also for you to ask questions about it. You can quote the answer to me and we can see what's going on. But and that's going to be sort of one of the problems of the course, is to see how, if some of you have Macintoshes, you may be easy, you may already have a drawing program or something that's easier for you to use with a mouse, but it's hard to sort of write out this stuff. Okay, so what I'm going to do now is, oh no, I don't want to do that. I want to share my screen, but I want to stop the recording.